Welcome to Snacks Weekly on Data Science. This podcast is all about making data science and machine learning knowledge accessible and less intimidating. Today, we are going to talk about large language model applications. This episode is based on a tech blog titled Evolution of the Udemy AI Assistant Intent Understanding System, written by their engineering team. You can find the blog link in this episode's description. Throughout this episode, we will explore this topic from both the business and technology angles. Now, let's dive in. On the business side, let's take a look at the problem to be solved. Udemy is one of the world's largest online learning platforms. It serves tens of millions of learners globally. It operates as a marketplace where instructors create courses across a wide range of topics, from software engineering to design and personal developments. And learners consume this content at their own pace. As the platform has grown, Udemy has increasingly invested in AI-driven features to make learning more personalized and engaging. One of these investments is the Udemy AI Assistant. The goal of this assistant is simple in theory but complex in practice, which is to help learners get what they need exactly when they need it using natural language. Instead of forcing users to navigate menus or guess the right search query, the assistant is designed to act as an intelligent learning companion. Learners can ask questions like, "Can you summarize this lecture?" or "Explain the concept in simpler terms," or "Help me find content related to this topic." And learners would expect a relevant and contextual response. For this experience to feel seamless, the system must first understand user intent, what the learner is actually trying to accomplish with their question. That intent determines what action the platform should take next, whether that's retrieving course content, generating an explanation, or guiding the learner to relevant material. At Udemy's scale, this intent understanding system needs to work reliably across many different learning contexts, languages, and phrasing styles, all while remaining fast and cost-efficient. So the core business challenge here is to designing an intent understanding system that can consistently map learners' questions to the right product capabilities. Getting this right directly impacts learner efficiency and user trust, as well as how valuable AI feels as part of the Udemy learning experience. Now that we've understood the business problem to solve, let's shift gear and dive into the technical side to see how the team tackled this challenge. At a high level, the AI assistant acts like a smart virtual tutor. When learners send a message, the assistant needs to determine what the learner's actual intends. That classification then drives which actions the system needs to perform next: fetch a lecture summary, or trigger an internal search API, or pass context to a large language model to craft a response. In the earliest version of the system, Udemy's engineers used a similarity-based approach to build on pre-trained sentence embeddings. An embedding is a way of converting text into a vector, which is a numerical representation that captures some semantic meaning. Udemy defined a set of predefined intents, like lecture search or lecture summarization, and then populated a small database of example phrases for each intent. When a learner message came in, the system would compute the embedding of the user's text and compare it to all the example embeddings using a similarity measure, and then pick the closest match. This initial approach was fast and cheap because it used a light-weighted model. and matching against a small dataset was efficient, and it worked reasonably well early on. But as the company added more intents to support more features, the classification model accuracy dropped. The similarity-based system started confusing intents that were semantically close, especially when the example set weren't rich enough to cover the nuance in real learner questions. The team also observed that adding more examples only marginally helped, and it made the maintenance much harder. Once it became clear that intent misclassification was the root cause of poor responses, the team revisited the approach. Their goals was simple: improve classification accuracy without substantially increasing latency or cost. Their first step here was to upgrade the embedding model. They evaluated several open-source models and found that a larger multilingual embedding model gave a much better performance-to-cost ratio. This larger model had a much richer representation capability and added support for multiple languages, important for a global user base here. But even this improved model struggled when the number of intents grew because the underlying similarity approach still operated on a single message embedding, and it often compressed important nuances of meaning. The next idea was to fine-tune the embedding model using real data where it had failed, which is a technique they refer to as hard negative mining. The idea is simple: to train the model to better distinguish between messages the old model confused. But despite many experimental tweaks, the fine-tuned embeddings didn't yield measurable gains. Here is where the team made a significant pivot: move beyond embeddings and use an LLM-only approach for intent classification. Large language models like GPT variants excel at understanding language in context and handling nuance. Instead of reducing the message to a single vector, the LLM could take the entire chat history and predict the correct intent based on more context. The team evaluated several large language model configurations, ranging from the full GPT 4.1 model to smaller versions like GPT 4.1 Nano. The goal was to maximize classification performance while controlling for latency and cost. The GPT 4.1 Nano model emerged as a strong winner in terms of performance-to-cost ratio. It delivered substantial improvements in intent accuracy with only modest latency and cost overhead. But there were trade-offs involved here. LLM-based classification still added about 0.6 seconds of latency on average to each chat response. And because it relied on an extra model invocation, it increased overall inference costs by about 10%. So the team arrived at a hybrid solution eventually. Rather than fully replace the embedding approach, they combined both methods. For each learner's message, the system first computed the embedding and checked its similarity score against the predefined intents. If the similarity was high enough, the system trusted the embedding-based classification and moved on. If not, it fell back to the large language model classifier for a more nuanced prediction. This hybrid approach delivered the best of both worlds. Most of the time, the fast embedding model could confidently classify intent, keeping latency and cost low. When ambiguity arose, the LLM provides a more accurate classification. In practice, only about 1/3 of learners' message triggered the LLM fallback, meaning the system kept performance efficiency while still improving accuracy where it matters most. The result is pretty clear. The team shared that the hybrid system correctly resolved a previously misclassified conversation, turning what would have been an incorrect lecture search into a right action of lecture summarization. This yields a much more relevant and useful response to the learner. Now, we've discussed both the business problem and the technical solution. Let's wrap it up. In this episode, we explored how Udemy tackled the challenge of understanding learner intent in their AI assistant. From a simple similarity-based embedding model, through experiments with larger models and fine-tuning, to eventually reaching a hybrid system that intelligently leverage both embeddings and large language model classification. This evolution demonstrates how real-world ML systems often require balancing accuracy, cost, latency, and especially in the AI features that directly interact with users. If you like the content of this episode, please subscribe to the channel. Give me a 5-star review and leave a comment. Your feedback is very appreciated, and I'll see you next week.